Hello, this is Mr. Wynn, and today's video will be about optimization with linear programming. So, linear programming is a method for finding the maximum and minimum values of a function. This is commonly used in everyday life with efficiency and constraints, such as minimizing costs, maximizing profits, minimizing waste, maximizing space, storage, things like that. The steps here are similar to what we've done before. You're going to graph each inequality in shade, find the overlap, that's the feasible region, find all the vertices of that region. That takes a long time, but we'll be using Desmos, so it gives all the points right away. Then we gotta plug each vertex in to the end or final equation, and we gotta select the greatest or the least result. So here's the one example. So we need to buy some filing cabinets. Cabinet X costs $10 each, takes up 6 square feet of floor space, holds 8 cubic feet of files. Cabinet Y costs $20 each, requires 8 square feet of floor space, holds 12 cubic feet of files. You have a $140 budget that you don't spend all that much, and the office can only hold up to 72 square feet of cabinets. So how many of which model should you buy in order to maximize storage volume? So the final question tells us our end equation, our profit equation. We're talking about how many of each should we buy in order to get max volume. So I'm going to do my final equation. So max volume, or let me do it like this. I'm going to say volume max. Volume max is, well, the X cabinet gives us how much volume? It gives us 8 cubic feet each. And the cabinet Y gives us 12 cubic feet each. Alright, that's not, I'm going to graph that. That's my equation to plug my vertices in. Because the feasible region will always give us, the vertices at least, will always give us the max and the minimum. So now I got to figure out what my equations are. So let's do the money problem first. Well, it's $10 for every X. And it's $20 for every Y cabinet. And our budget is no more than $140. So less than or equal to $140. Alright, let's do the square feet, the floor space equation. Well, we have X takes up 6 square feet each, and Y takes up 8 square feet each, and our limit here is no more than 72. And this last two that people usually forget is X has to be greater than or equal to 0, because you can't have such things as negative closets or cabinets. Same for Y. Y has to be greater than or equal to 0. So I'm going to graph all 4 of those. So the first one is in standard form. I'm going to do the cover-up method. Cover-up method says 10x equals 140. Divide by 10, x is 14. That is the coordinate, 14, 0. If I do cover method, I'll do 20y equals 140. Divide by 20, y equals 7. So that is the point, 0, 7. So 14, 0 is somewhere over here. 0, 7 is right here. Connect it, it is solid. And let's see, test point 0, 0. Well, the left side turns to 0. Is 0 less than or equal to 140? That is true. I'm going to shade the bottom part. So everything down here is being shaded underneath this red line. Alright, the next one is also standard form. I'm going to do cover-up method. 6x equals 72. Divide by 6, you get 12. So that is the point, 12, 0. Cover-up method again. 8y equals 72. Divided by 8, y equals 9. That is the coordinate, 0, 9. So 0, 9 is slightly above this. 12, 0 is slightly below this. It is solid. I'm connected. And test point, I'm plugging 0, 0. Well, the left side turns to 0. The right side stays the same. 72. Is 0 smaller than 72? That's true. I'm going to shade everything on the side of 0, 0. Alright, now, the last two, x has to be positive, greater than 0, y is positive. That just kind of blocks us off to everything right of this line and everything above this line. So you want to see, here's our little region here. I don't need the whole graph. I just need this part. So there are a couple points I need. I need the origin. I need this intersection. I need this intersection and this intersection right here. So the rest of our graph does not matter. Only this part matters. So we're going to use Desmos to figure out what those points are. So here's Desmos. Here's the first line, second line, third line, x is positive, fourth line, y is positive. Now the little triangle, I just tap the points, is 0, 0. This one is 0, 7. This one is 8, 3. This is 12, 0. So I'd be pretty amazed if you could guess one of those was the answer for the cabinets. I mean, some kids think 6 cabinets of X and some other number for Y. But which one would be one of those answers? That'll tell us the best one and the worst one. So now we have our points. We plug into our final equation, our volume max equation. If I plug in 0, 0, well, volume max for 0, 0, 0 times 8 is 0, 12 times 0 is 0. That's 0. Okay. That's that one. If I try the next one, 0, 7, volume max, 0 for x, plus 12 times 7 for y. That gives me 0 plus 84. That gives 84 volume. So that's better than 0. I'll try the next one, 8, 3, volume max, 8 times 8. Plus 12 times 3. Well, that's 64 plus 36. That is 100. That's even better than 84. In this last one, I'll go over here on the side. Volume max would be 8 times 12 plus 12 times 0. That's 96 plus 0. That's 96. So now I know how much space each point gives me. The lowest would be 0, 0. If I buy nothing, I get no space. That's the most inefficient way to do it. The second one only gives me 84, which is not the highest. That's the third. The other one gives me 100, which is the highest. That's my best. And this last one gives me 96. That's the second best. So the most efficient way to do this is to buy 8 X cabinets and 3 Y cabinets. So again, graph each, find the points using Desmos, plug those points into your end or final or profit equation, see what gives you the highest number if you want the best, or it gives you the lowest number if you want the worst. All right, here's your practice problem. Try it. I put the graph there for you. You get those points. You just plug those 5 points into the profit equation and see what gives you the highest number. All right, that's Mr. Wynn. Thanks for watching. See you in class.